Welcome back, geometers. Yeah! All right, cool. So, angles, they're hard to define as well. Could you draw an angle on your page? How many lines or segments or rays, whatever of those you want to pick, how many would you need?
Two.
So you could get by with one maybe if we want to be like really specific with it. But I think we're probably in agreement that most of the time we're going to draw them something like this, right? Okay. So if I wanted to have an angle, we need a few different things. We can clean up this definition as we go, but we'll just say it is the region. By definition, we'll say that it is the region between two, and then here's where I don't want to have to write all these words, but I've done it between two segments right now. I've made an angle using two segments. I didn't name them, but can you guys see that and agree with that? Okay, check it out. I'm about to change it. Is it still the same angle even though I do it between rays instead?
Yes.
Okay, we're about to get real crazy. They don't match perfectly, but pretend they do. Did I still form that same angle between two lines? So I don't want to have to write lines, rays, or segments over and over. I'm just going to say rays right now with the understanding that it could be all of them. Okay, these two rays, if that's what they are, they have one thing in common. One single point right here. What do we call that pointy part of the angle?
The point?
So you're not, like, it is a point with a common, and it starts with a V. Vertex. So the point where these angles join is what we call the vertex. If you think back to Algebra 1, you may recognize that word dealing with the parabola, but it's the same basic idea as we look at it. Now, for naming these things, a couple different ways that we can do this. Notation, and I 6th hour or 5th hour, I don't know, my next geometry class, theirs is so much more structured because everything that felt kind of clunky in here during 3rd hour didn't 5th hour. So, okay, notation. We can write these things down using 3 points. And I'm going to put 3 points on this. And I'm going to name them real quick. So let's see. We have angle. So I'll use point A up here. N and G here. A and G are the 3 points. Okay. How would I name this angle? What 3 points should I use? Is there a particular order? Can I just list all 3 of them out? What do you think? We have to have the vertex in the middle. And we'll see why that is. We need a little bit more complex picture. We'll say 3 points with vertex in the middle. Now, the word angle is going to show up like a million times exaggeratedly this year. Okay, when we write these, my notation that I use for this, the shorthand, is for this one example, I use this as my angle symbol. I have an angle and an arc across it. Angle and an arc. An arc is just a part of a circle. This is what I use. Yes, sir.
You have to do the arc?
You don't have to. My concern and why I encourage you to do it is because if I'm trying to say angle, you can also name them with numbers, but we'll talk about that. But if I have a statement that says angle 1 is less than angle 2, angle 1 is less than angle 2. There's room for ambiguity. Like, your call. Yeah. Be careful with it. Yep, you're good. You do not have to use it with the arc. I will every time. So if we're going to name this angle right here, for example, what's the vertex point of that angle? N. Okay. I'm going to add one more point on this, and ANGL. Is there another? That didn't change anything except I got a new name, right? Okay. Can I name this angle ANG? Is that okay? Yes. Is there another way we can name it? Yes. Give me another one. LNG. We still identify that LN represents one of the sides of my angle, and N is the middle, the vertex. Give me another way to name this. GNL. Good night. I don't know, L. One more. Raylene, give me one more. NLA. So careful. What has to go in the middle? Okay, so we can't use L. You say LNA? Or I don't remember what you said, I'm sorry. Okay. With that, I like ln, but if I say go from L to N to A, did I really make an angle? No. When you're thinking about it, if it helps, just make it the path. If I go from L to N, where's the next place I have to go to actually make this angle? Boom. So there would be LNG. And that's one that we have. We could go GNA is the other one that exists up here. Okay, as long as N's in the middle. Now, from time to time, if it is completely clear, and I'm not going to write this one down, but we'll just talk about it. If it is completely clear that that's the angle that I'm talking about, you may just use the one name. Right now, angle N, I think it's safe to assume that this is the angle that we're talking about. We'll see a situation here in a minute where it wouldn't be as clear. Beyond the 3 points, because I hate using the 3 points, when I do, like, when we'll get to proofs and we're working with triangles, I don't want to have to use 3 letters over and over to talk about different angles. Really common to put a number right there. We can call it angle 1. Okay, Greek letters are another really common thing to use, but I will try my best to just use numbers. Okay, from this, I want a quick thing from putting all this together. We are going to draw an example, and you're going to sketch a single illustration for me that has a bunch of characteristics. So here we go. I want you to sketch. And here we go on A. I want you to have plane R, so I'm going to use my fancy R, with the following characteristics. All of our pictures will look different. Just a heads up, I will probably pick up your notes and I will put your picture up on the board so we can see if you are wrong or right. We probably won't have time to do it for everybody. But plane R, what should we add to plane R? Okay, so let's say I want angle MBC. All right, but I also want somewhere on here is I want this thing, and I'm going to stop saying what they are. I'm just going to write them. I want this thing to be on there. And I want, let's say, C, D here. There's one more. Let's go with this thing. I want you to draw me a plane R with all of those things on it. Is this a problem that you feel confident trying on your own, or is this one that we should try to do together first? So check this. I have a crazy groundbreaking thing. If I ask a question, like specifically about where you're at comfortably with this, I care where you're at, right? The question's not just to fill the empty noise. Thumbs up, yes, I can do this on my own, I think, or thumbs down says, I don't know what the hell's going on. All right, let's do a part or two together. Okay, I'm not picking on anybody. We're all here to learn. It doesn't matter if your thumb is down or up. If you gave me it down, I appreciate that. Raylene, which one do you see that goes, oh, I don't know. Like, where do you run into issues as you think about it? Okay, how did we draw a plane yesterday? What is a plane? Did we draw a plane too somewhere? I think we did. I can see one on your page. When I draw planes, you don't have to do it like this. It's just this thing. It's this flat surface. And what is the name of this plane? One more time. I think it's B. We're trying to sketch plane R. I'm going to call it R. Like we know what it's called. It was B yesterday. Okay, so there's R. Awesome. There's my plane R. I want to put an angle on it, MBC. I need to put 3 points on my line then. What should those 3 points be? M, B, and C. Cool. Because I want to make it an angle, I didn't specify, so you could make a weird answer. But I'm just going to put 3 points here so I can draw an angle. Does it really matter which one I name what right now? No. Andrew, what's this point right here? M, B, or C? Mike, Bravo, Charlie. M, B, up here is, again, you can put them anywhere. Okay, if I want to make this angle MBC, What's the vertex, the pointy part of that angle?
MB. Oh wait.
What's the vertex, the pointy part, the middle of my angle? Why M?
Because they go out different ways.
So when you make that decision, Andrew, are you looking at this picture to make that decision?
Look, I'm looking at like the triangle.
Okay, so but you are looking at the picture here. Check it out. Don't look there. Which one's the vertex? It goes right in the middle of everything. B has to be my vertex. So if I'm trying to draw angle MBC and I don't want anything additional, I'm going to go ahead and draw them like this. There's the angle that I'm talking about. This is angle MBC right here. Now, I've done it with segments, but did I specify that they had to be? No. I could have drawn a line coming out here, and that would have been completely fine. All right. So I've got plane R. I've got angle MBC. I need a, gosh, what is this thing? M I have. I need to put a point V somewhere. What is this representative of, Vincent, for V? This symbol means what?
A line.
It's a line. So does it matter where I put point V?
Yeah.
Why?
A line.
Why not?
Because you aligned it infinite, so it'll. I mean, as long as you draw straight between M and V.
Yeah.
It doesn't matter where.
Absolutely. I could put point Victor right here. It would be fine. Because then I would just have to say, check it out. It goes for infinity. This works. Now, yours, you can do this one. You cannot do this one. It's up to you. Another way to do it, and there's not a single right answer. Could I put point V here? That didn't break my angle at all, right? I still have angle M to B to C. Could I then just say, check it out. Here's line MV. I still have angle MBC. It looks a little different now, but both of those circumstances are completely fine. I have a line now. I need BA. And what does this mark indicate that it's going to be? A is for Andrew. Not a line. There's no arrows. If you have to check your notes from yesterday.
Segment.
And do your notes specify, like it shows this clearly in your notes, that a segment has this bar above it?
No.
You should add that.
Yeah, use X.
Okay. Yep. Make sure, like, we're going to practice with these. But if I need BA, I already have point B. What else do I need to add onto my graph then, Raylene? So we're here.
No.
No, you're good. I have B. What's the other point I need? Does it matter where I put it? Why? Where do you want me to put it? You top right, bottom, top left, like wherever. Tell me where, anywhere. Sure. If I put it here and I call this A, can you make a segment that joins B and A? It'd just be this, right? If I'd put it over here instead, can you still draw a single segment that joins B and A? So one more try. Does it really matter where we put it? As long as it's on the plane, I'm good.
So
And it, go ahead.
You put it in between B and C.
I could absolutely put it in between B and C and have less to draw. With this one, it doesn't explicitly show, but I certainly do have segment BA. It's just hidden on a larger segment. Okay. Whether, I'm trying to think how to word this. We're good. Okay. Got it. BA. CD. What else do I have to add to this thing, Lily? Array. And it starts at which point? And it ends never, because it's array, but it passes through which other point? So anywhere that I start at C and I go through another point forever, I would call that my array. Just to fit nicely in my picture, I'm going to put it here. What does this point have to be? D. Got it. I now have a ray CD on my figure. One last thing, Z for Ashley, but that doesn't really work the way that I wanted to, but that's okay. Where should I, what is Z representative of? A point. Where should I put point Z?
Anywhere.
Literally anywhere. Pick your favorite place. This part of my drawing is missing a little stuff. We have it. Okay. Doable.
Yeah.
All right. Do we want to try one more? Sweet. So this one, do you want it same way you sketch it from characteristics, or I can draw a big plane and I can ask you to identify all the stuff? Okay. So on B, you guys are going to help me though, because I don't have this exact example in the book, and we're just going to see. I want plane. We're going to switch it up a little bit. X, Y, Z. Okay. I want, what else? Deal. I want you to draw me angle ABC. I also want angle, a different angle, just to be clear, DBF. I want you to have, I don't know, a ray. Let's call this X, nope, not going to use, yeah, I will. XQ. And I want this thing, whatever it is. We're going to say that this is AL. Al, obviously. Cool. I want you to draw me plane XYZ, angle ABC, angle DBF, ray XQ, and segment AL. Cool. I'm going to pause it so that we don't have to just quietly have blank on the video. And I'm going to come around and kind of...
Does it really matter what shape you use?
For the plane?
Yeah.
Not at all.
No.
This is just my default so that anytime I draw this shape, you know I'm drawing a plane. You could draw a circle if you wanted to. Like, I wouldn't. You can. Right off the bat, I think everybody who was able to finish made the same mistake. If I want to name a plane with a single letter, I use that fancy capital italic, right? What if we name like this, but without any fancy italics? These are three whats? They're points. You can name your plane using 3 points. If in your picture you have simply XYZ written in a corner, totally understand why you would do that. You're trying to treat it like it's the R, right? But if I'm naming it with the points, these are 3 points that are not on the same line. That's what we talked about yesterday. I'm going to start with those 3 points. Don't care which one's which, and you can have them all in the one corner if you want, but check it out. Here's point X, here's point Y, and for no particular reason, I'm going to put point Z over here. We have 3 points that aren't on the same line that we can use to name our plane. Like, that's all that we've done. That was a mistake that almost everybody had. Now, starting here, we have angle ABC. What's the vertex of that angle? B. So I'm just going to sketch some random angle in here. And the second I sketch this, I know that this point has to be what? B. And I'm going to move that actually right here, and we'll see why. So if that's B, what do you want this point to be? That could be A. Could it be C as well? Yeah. Like right now we're just building it. But if that's A, that's B, that has C. Alpha, Bravo, Charlie. We got it. Okay. This has B as the vertex, right? Point B is my vertex, and we just drew it. What's the vertex of this angle? Can B be 2 points, like 2 locations, or is it a single location? So whatever my angle DBF is, it has to use this one. An easy way to do this is just to tack it on right here. We have D to B to F. Cool. Yes? Perfect. I think perfect. Let me double check. Based on the directions I wrote, absolutely. I did ask that it would be a different angle because they are the same. Don't change yours. You've drawn me 2 angles that happen to be the exact same angle. It will be more specific. This is just us practicing. That's a great question. If you didn't catch that, Ashley's question was, what if she put D here and F here? Is there still a DBF angle if we do that? D to B to F. Like, it's still there. It happens to be the same angle. That is A-okay unless specified, which I didn't write it down, so that's fair. Okay. What if I want XQ? We need an X. We already have it. And it's a ray, so I need what other point? So there. Anything else I need to add to it? Q. Where? Anywhere on this ray. So I'm going to put it here. Same thing. AL. A. L. It's a segment. Thank you. Good catch. Now, this does bring up a really interesting useful, maybe interesting. I don't know if you find it interesting or not. I don't want to make any promises. Uh, when we talked about naming angles, how many points do we use? Three. Now, in this situation right here, on this picture, in this picture alone, if I say angle C, do you know which angle I'm talking about?
No.
This is point C if that's not clear. If I say angle C, I think it's reasonable to expect you're going to assume this angle. Now, Ray, you might have some additional knowledge that you're thinking, maybe not. For our purposes, I think this is reasonable to call this angle C. If I say angle B, is it really clear whether I'm talking about this or this? No, because they both have B as the vertex. In these situations, you must use all 3 points or the numbers to be able to specify, because two ways it's unclear. Everybody cool with that? All right, we are gonna blast through the rest of the stuff. I'm gonna give you textbooks today. Whether you want to use them like full time or not is up to you. But I'm gonna give you textbooks. Do you want to grab them now to take a quick break, or do you want to just finish the lesson and then get textbooks? Okay, quick break. Again, I can't stress, I'm so sorry that the first section's like all vocab stuff. I know it's really dry. It's not the most fun. I'll get it. Cool. All right. We get to learn some mathy words today that you guys have never seen, I don't think. Has anybody ever heard of a theorem? What's a theorem? So it could be that one. I think more commonly, the one that people think of as a squared plus b squared equals c squared, or x squared plus y squared is z squared, whichever one you learned it as. That is the Pythagorean theorem, because it was discovered by a crazy group, we're just going to call it what it is, a crazy cult called the Pythagoreans that were led by a guy by the name of Pythagoras.
They're really bad.
They did some crazy stuff. They murdered a lot of people because of their belief of numbers. Anyway, not our focus. Totally lost. Yeah, the theorem part of it. Tell me something true. Okay, so that's true. Here's something interesting with it. Will that be true in a million years? I don't think anybody knows. Andrew, do you identify as a boy?
Yeah.
Are you going to be a boy in a million years?
Yeah.
Are you? Are you going to be a human in a million years?
We're quite dead.
So if you're dead, does it make sense to say you're a boy anymore?
Yeah.
Like, even when you're dead, is your skeleton or whatever, in a million years, there probably wouldn't be much of a skeleton left. Is it going to be anything other than just like the leftover elements and stuff? Like, that's a weird thing to think about, right?
Wait,
And
what,
I think, sorry.
what about like 1 plus 1 equals 2?
Well, that seems like maybe we don't need a physical existence to be true, right? The Pythagorean theorem is true today. Like, it's been proven. Will it be true in a million years?
Yes.
Yeah. Here's where I don't know the exact answer. I know my beliefs. Was it true before it was discovered?
Yes.
Like, I think so. I think that it has been true since the beginning of time, essentially, because we've proven it's true. It will always be true. If it will always be true, it must have always been true as well in the context of math and logic and stuff. Theorems are special like that. People say diamonds are forever. Like, those commercials have kind of fallen off. Two comments. One, diamonds are not a great thing to do. You've been lied to and made to think that they're super romantic by the powers that be and have money to advertise. Diamonds do a lot of great things, but on the ring of your loved one is not a good use of your money, I don't think. Nor do I think that they come from a good place, depending on how they're made. Yep, if they're made, fine. Pay a little bit of money for a diamond. But if it's some like 10-year-old kid who's going to get his fingers chopped off if he doesn't collect enough, I would be apprehensive. Blood diamonds. I would be apprehensive about buying that one. Lots of gemstones have a dark history. Not our focus still, though. However, diamonds are not really forever. Diamonds will eventually disappear. Theorems will not. Theorems are forever. They are forever. They always have been. They always will be. These things are always true. They're proven logically true. Now, for mathematics, we build up our whole understanding of mathematics. We represent the world with certain symbols and stuff. The symbols and things, we make them up, absolutely. The number 4 that we write doesn't exist prior to humans. But does the concept of 4 things exist prior to humans existing?
Yes.
Yeah, humans came around to name it 4, but that concept of 4 objects has always existed, and until there's nothing in the universe, it will exist. With that in mind, We have some things that we can prove to be true. Those are called theorems. On the other side of that, we use mathematics. We treat it as what's called an axiomatic system, which is a really fancy word. We have some basic assumptions that we make about mathematics, and then the rest of it gets built up from there. The things that we don't have to prove in math, they're going to get one of two names. It's either going to be an axiom, which is a really fancy true word for it, or more commonly, at least in modern math, you're going to see it produced as a postulate. So we're not going to define the word postulate, but you're going to make you all say it once. A postulate does not need to be proved. It is assumed true. You cannot prove a postulate. We just say this is true, and then we go from there. Okay, postulate. Do you have to prove it? No, you assume it's what?
True.
True. So check it out. The way that I'm going to organize these postulates that we're going to get, because we have to build up the basic system, we are going to introduce a couple postulates right now. They will have a name, but they'll also have a number. When we write our first one, so we're going to just go ahead and say basic postulates. So same section still. I didn't introduce a new section, but it's a new header. Instead of working within our key, what was the first header, I suppose? Sorry, basic postulates. I'm just going to look back. We looked at geometric figures. Now we're going to look at basic postulates. Okay, so there's two of these that we're going to deal with. The first of these, and I'm just going to shorthand POST for postulate. I'm going to name this 1.1. What chapter did this postulate show up in? Chapter 1, and it is the first postulate of this chapter. Postulate 1.1, we are going to call the ruler postulate. Now, as you work with me in the coming years, we are going to refine and make our mathematical language better and better each year. This particular postulate, what I think that we should do is, if we can make sense of it with a picture instead of having to write sentences and stuff, I think that would be better. Let's try it. And then if we need the sentence, you guys are going to be honest with me and we'll write a short sentence to explain it. So check it out. I'm going to draw a little number line here. That's all I'm going to do. So check this out. Here's a number line. And I'm only going to put two things on here. 2 points. Now, we can name it. And I'm just going to name it and put a number. So let's say that this is X and this is Y. This is 3 and hypothetically this is 7. We have a number line with 2 points. Okay. For this, if I wanted to put another number 3 on that line, would it be a different point? Like, yes. Here it is. Here's the point that represents number 3, right? Watch, I'm going to put another one. Did I do a different point? Maybe I drew another layer of ink or whatever you want to call it, but if I'm talking about the location when it's 3, there's only one single location where that's true. There's only one of them. So what this ruler postulate tells us right off the bat is, from this postulate, each number, any number that exists, has a unique spot on a number line. Everybody okay with just that first little idea? Every single number has a unique place. 2 represents 2. It's not the same as 2.1. It's not the same as 2.3. They're all different, which that's obviously something that you've dealt with and something that you've used. We've never called it a postulate because we've always just assumed it's true. Okay. Now, for this, there are some natural extensions that we come from this. In theorems, they have very different language. I am going to make this a tilde. But underneath, I'm going to go one step further still. As an extension beyond this, another way to word this is that it means that there must always be some measurable distance between 2 points. Between 2 points, any 2 points that you ever give me, there is a distance. Now, this book, I don't think does it. In our old textbook, this had a really wonky name. This idea was called the betweenness of points. There, thank you. Between 2 points, any 2 points, there is a distance. Okay. The bell ringer for yesterday, we were looking at number line, I believe. Is that this class? Yep. And I asked you guys to calculate the distance between 2 points, right? You were using the ruler postulate to do this. Okay. Didn't have to think about it. I just want to make sure that we can build up our system as we're going. Are you guys, just as a quick example, find me the distance between x and y?
4.
4. How on earth did you do that so fast? So we're going to introduce, 7 minus 3, right? So check it out. You probably don't have to show much work, but I want to introduce a little bit more notation. Is xy a segment or a ray or a line? Just xy. It could be all of them, realistically, right? If I wanted, like when you answered that question, you were treating it like a segment. Okay. If I want to know the length of segment xy, and you can maybe do this less wordy than you need to, the length of segment xy, if we want to talk about its length, we change notation a little tiny bit, is, and you guys just told me the number, right? Okay, when we write the length, so we don't have to use this word every time, if I want to know the length of segment xy, I just don't put the bar above it. And what was its length you just told me? 4, and you did that by taking, you probably didn't do all this, but realistically, it's the absolute value of 7 minus 3. If you just did 4, I'm okay with it. I really want this part to shine through and stick out though. If you see xy written like this without a mark above it, what is this? The length or the measure of the segment xy. It's really subtle, but if I said draw xy and I didn't put the mark above it, you couldn't do it. If I say what's the length of segment xy and you give me the bar above it, you're not giving me the right thing. And I know it's really subtle and I won't like destroy you for it, but I will always comment. I want us to get in the habit of writing things correctly. Okay. Beyond that, we have the lovely ruler postulate. There's one more postulate we're going to introduce today. So I guess in your notes, it'd probably be underneath. So I'll keep it underneath. If the first one was the first postulate of chapter 1, this is going to be the which postulate? So we'll call this postulate 1.2. Now we had the ruler postulate just a second ago, but we also get the protractor postulate. And I promise once we get a better feel for how things go and I can read you guys better, like the pace will match more. Hopefully it feels a little warmer today than it was yesterday, but we'll see. Okay, protractor postulate tells us the following. If you give me 2 rays, for example, that come from the same initial point, and I'm going to draw those, so give me a ray. XB, like Bravo?
Yes.
All right, so here's ray XB. There it is. Okay, if XB, this ray, happens to share the same point X, can I make another ray from X?
Yes.
X, Y maybe, or XR, doesn't matter. So we have an angle right now. I agree with that, but we're almost there. There is an angle between it, right? 100%, you notice that right away. What angle does it look like? Is that safe to assume that it's perfect? If we want to assume it's 90, we'll have to add one more thing, but we're not calculating the stuff yet. The ruler, sorry? The box. It'd be if we want to make sure it's a 90 degree, I would put a box right here. Okay. So as we're looking at this, what this postulate actually tells us is that there is a rotation between these 2 rays every single time. There exists a rotation between, what's the smallest possible rotation that wouldn't even really make sense to talk about? Less than that. Less than that. Because even 0.0001 is still a little bit, right? Is there a really boring one? Check it out. I'm going to spin. 0. Anytime that you ever give me 2 rays like this that form an angle, there is a rotation between 0 degrees and 180. Love it. 180 degrees. There exists. Can I just stop here? Okay. Could we say to move from one ray to the other? But I'm okay with just stopping here. Okay. Every single angle that you ever draw will have an angle between them, between these two rays, between 0 and 180. Now you might be thinking, what if an angle is bigger than 180? So don't sketch this, but I'm just going to want to talk about it. Let's say I wanted this angle to be the one that we're looking at. That's bigger than 180. Did we just break the protractor postulate? I'm going to say no, but I want to know why not. Because that's bigger than 180. Could we go less than 180 here? So we can still get there. That's our postulates. What it's telling us can happen. Now, it might be talking about a different measure there, and that's okay. All right. Go ahead. Yeah, like you're never going to get bigger than that, ever, ever, ever. Okay, there are two more postulates that we get. And I'm just going to sneak this in as one single one. Okay, last thing that we're going to write, we're not going to have homework today either, unfortunately. Sorry. All right, so we're going to differ a little bit from your book with this one, just so you're aware. I'll try better to keep them like in line with one another. But last one, 1.3, I'm going to say segment and angle. And check this out. Do we have a shorthand for angle? Because we're going to write that word a million times if we don't want to shorthand it. I will use this like all the time for angle. We have segment and angle addition. Postulate. The segment and angle addition postulate. Your book presents these as two, but I don't think we need it. I'm going to see, without any words, if we can make sense of this. Okay, so check this out. I'm going to draw the segment first. And I'm going to see if you guys can help me make sense of this segment addition postulate. Let's say I have 3 points on a single segment. Cool. We'll call them A, B, C. If we don't know any numbers yet, that's all right. We can put numbers. AB, let's say, is 10. And what's BC? If we try to roughly to scale. 5? I believe that. Here's my question for you. Again, it's a postulate, so it's something that you are likely to assume is true, but I just want to make sure we all agree that this is true. Can you find me the length or the measure of segment AC? Oh my goodness, how did you do that? If you give me any segment with a start and an end, can I put another point and make it the sum of those? We can add up pieces of a segment to get a larger segment. That's all this is saying. You would naturally do this, I think, but we do, it's a postulate. We get to say that this works and it's true. Okay, could I add another point and it would still be true? Yeah, it could be AB plus BC, and if we want this expressed out the other way, without numbers, we would say, hey, the length of AC is just the length of AB plus the length of what? I try to go consistent, but you were right. I just try to go left from right, and I stick with it. But yeah, this is exactly what we did. We could do it with numbers or without them. All right, you ready to get real wild? We'll see if you guys can get this one too. All right, I'm going to draw this. This was the segment addition, because we're working with the segment. And let's say that this is point K, Y, L is over here. And then on the interior of this angle, I'm going to have YE exist as well. All right. So just like we saw when we have a segment and the length of the segment, we have an angle and the measure of the angle. We are going to introduce a new notation here. This does say Kyle, in case anybody was wondering why I picked these points. Like, yeah. Okay. Does everybody see angle KYE?
Yeah.
Okay. Was it this? You don't have to draw it on yours. Is it this one? Okay. If I ask you for the measure of angle KYL, we can't just write angle KYL because that's the physical object. The measure of it, we will always write with the M, like for measure, of angle KYL in this case, because it's the one I'm asking about. Are there smaller angles that we could add up to get that larger one?
Yes.
What are they? Let's see. Raylene, I want this big angle here. K to Y to L. I'm looking at right here. What's one of the two smaller angles that I could use to add up to that big one? Start at K, we go to Y. Where else could we go? E. I could take the measure of KYE. I agree with you. The measure of angle KYE. Andrew, what would I have to add? If I want the whole big angle, it's this KYE plus what?
L.
L doesn't work. L's a point.
Oh. Wait, what was the question?
What else do I have to add? To get the big angle, I take this angle, KYE, and obviously it's going to be this one, right? How do I name that one?
EYL.
EYL, love it. Or LYE would also be okay. Just the L doesn't work. Boom. We can add up the smaller parts of an angle to get the whole angle. That's all that we're saying with this. All right. We are at a really awkward spot right now because what did I tell you about homework about 30 seconds ago?
No.
I'm going to stand by that. I should not have said it. We just finished this section. I really want to give you guys homework. We will spend some time working on it in class and start our next lesson on Monday. Okay. Your textbooks, do not leave them in here. If after a week or two you decide you don't want it anymore, you can check it back in with me. I'm cool with that. But I'm going to make you take them. Keep them in your locker. Take them home if you want. Get in my Google Classroom. That is your homework. Everybody internalize it. Sign up for my Google Classroom. Do you have a cell phone? I think you get your computers today if your folks sign the form.
Yeah, we're supposed to get them next period.
Okay, Ray, I will help you. Has to be a school email. All right, later Raiders, have a good weekend. Go swim tonight. Is this third hour?
Yeah.
Okay.